Okay, folks, first thing we got to do support reactions. That's the first step. So again, we got a pin down here at A. Pin has two reactions. We had a roller over at B. You know, roller just has a reaction perpendicular. Sum of forces in the x direction. I showed RAX going to the left, so I'll say negative. So RAX equals 500. So it does act back this way. You got 500 going right, 500 back to the left. Some forces in the y direction. You got RAY and RBY. I show them acting up. You got 1,000 acting down. Okay, you can't solve that yet. You sum moments about point A. Point A, you get to cancel out the RAY, the RAX. You get to cancel out the 1,000 pounds up here at the top. You do have the 500 times 5 feet away. That's going clockwise. In this case, I'm going to call clockwise positive. You got RBY, 5 feet away. So you can write your moment equation out. RBY is equal to 500. I can substitute that back into the y equation, and I can find out that RAY equals what? 500. Right? 500, 500. Okay? So, I'll let this suffice as my big picture. I've got 500 this way. I got 500 for RAY. I got 500 for RBY. And I'll let that be my big picture, and I'll sort of move on. Now, the first thing that I'm going to do is I'm going to choose a joint and draw a free body of it. The first joint that I'll choose is joint A. I'll draw a free body of joint A. I got to put my known forces on it, which would be 500 pounds up from my reaction RAY, and then 500 pounds to the left from RAX. And I have two forces, or two members, excuse me, that have forces, that creates joint forces, and that would be from AB and AC. Now, I will do this. I will always draw, to start out, my joint forces acting away from the joint. That'll sort of be just my common assumption. Okay, and I'll tell you why that is in a minute. So, go ahead and work out the equilibrium equations for joint A now.